any questions there? We're going to sort of pivot now and talk explicitly about deep learning and some of the cool stuff going on in deep learning. But I'll pause here and see if there are any questions about the material so far. All right, we'll keep going then. So deep learning, which you will hear over and over for the next 2 days, is a very, very old idea. It goes back to actually the 1940s. And it refers to training artificial neural networks. So we're going to unpack sort of that whole phrase in just a second. But it really took off about 10 years ago, and we'll go through some of the history of that as well. It has really come to dominate the entire field of machine learning. That essentially most of what goes on in machine learning and most of what goes on under the umbrella term of artificial intelligence is really people training big artificial neural networks. We're going to build one of these kind of by hand tomorrow, but I want to give you just a sort of a conceptual introduction today so that you can let that marinate and be ready to go tomorrow. So I'm showing you an example of an artificial neural network, a graphical representation of an artificial neural network over here on the right-hand side of the screen. And all of these little circles are artificial neurons. And so these artificial neurons are called artificial neurons because they're loosely modeled on the way that biological neurons work. So the way biological neurons work is imagine that you're a neuron in your brain. You really only have one job, and your job is to turn on and fire an electrical signal downstream to your fellow neurons that you're connected to every time the neurons that you're connected to get excited about something. So I'm going to sort of look over my shoulder at all of the neurons that I'm connected to. And when that group of neurons is sufficiently excited and firing an electrical signal, I'm going to then turn on and fire my electrical signal up the line to neurons that I'm connected to. And neurons are connected by things that are called synapses. They're just sort of transmission lines in your brain. And these lines in this diagram are kind of like artificial synapses. So you can see that they are the things that connect the neurons to each other. And so these artificial neurons are just going to do the same thing that I just described that biological neurons do. So this one right here is going to turn on and fire when this neuron, because it's the only thing that it's connected to, is sufficiently excited about something. And so it's going to turn on and pass along its message downstream or upstream to all of the other neurons it's connected to. So that's the big idea with artificial neural networks, is we're going to write this down as a computer program of this interconnected network of neurons that turn on and fire in response to stimuli. And the sort of magic thing is the only thing that's going to change about these artificial neural networks when we want them to learn to do something is we're going to change the strength of these synapses. So these synapses are just numbers that we can make bigger or smaller. And when we want a neural network to learn something, we're just going to find a good combination of those synapses that result in it being able to do the thing that we want it to do. That turns out to be a very successful approach and a very general approach. And again, most of these pieces were in place as early as the 1980s. But what changed is that computers kept getting faster and data sets kept getting bigger because of something called the internet. And so now there are big artificial neural networks that are essentially trained on the entirety of the internet. So all of the text data, all of the video data, all of the imaging data. And what has really made these things so powerful is that the more data you give them, the kind of better that they keep getting. And so that has been the reason why deep learning has taken over, and why, honestly, I'm here talking to you today about deep learning, because it just works so well because now we've collected so much data and have such powerful computers. And they've honestly provided solutions to some of our oldest and hardest problems, and I'll touch on a few of these in the rest of the lecture. So let me just stop here and say, who has ever interacted with a deep learning model? So maybe I'll just pause here and ask if anyone has any experience interacting with a deep learning model in any capacity. So if you have, raise your hand. So a little bit, not that I'm aware of. Okay, so it seems like no one has. I'm here to tell you that you're all wrong. All of you interact with deep learning models every day of your life. Because if you've ever uploaded a video to social media and the contents of that thing has been tagged automatically, there was a deep learning model that was tagging your face, that was tagging all of the contents of that image. Essentially, if you've ever uploaded a picture to a social media website, you have definitely interacted with a deep learning model. Facebook, or I guess Meta's now, deep learning models tag something like 1 billion pictures today per day. Instagram does something similar. If you've ever interacted with your smartphone, you've interacted with a deep learning model. Anytime you talk to Siri or another smart device, the thing that is interpreting what you are saying to it and producing the text on the screen is a deep learning model. Likewise, if you've ever heard Siri's voice or any of your other smart devices' voices, 100% that is generated by a deep learning model. So your smartphones are packed with deep learning systems. If you turn on the automatic transcription for this Zoom call, the thing that is doing that automatic transcription is a deep learning model. So it's so ubiquitous now, and I think works so well that you all interact with it every day. You're probably just not aware of it. The other point that I would like to make is that we're going to talk about neural networks as kind of one thing, but they're actually more of a family of models and a family of algorithms. And so if you have tabular data, so if you have Excel data or data that fits sort of in just a neat little table, people will talk about a neural network called a multi-layer perceptron. And this is the neural network that we're going to build tomorrow. We're going to build a multi-layer perceptron, go through all the nuts and bolts and figure out exactly how it works. If you build a neural network for imaging data, you'll hear it called a convolutional neural network, or CNN. And the high-level abstractions for CNN stay the same as they do for multi-layer perceptron. Some of the individual components will change, though. One of the things that I'll try and convince you of tomorrow is that neural networks are an awful lot like Legos. And so when we have an image model, we're still going to be using Legos, but we may swap in some image-specific blocks to help us build that model that sort of give us an advantage when we're modeling imaging data. And the other sort of last kind of neural network is when we have time series or sequential data. And that's often called a recurrent neural network. You also see it called a transformer, which is a slightly different kind of model. So sequential data are things like text data or speech data or anything when there's kind of a sequential or temporal dependency. We're again going to use a slightly different kind of neural network that takes the specifics of the data that we want to model into account. Okay, so any questions there? I think we're pretty good on time, so I'm happy to answer any questions. The sort of second half of the talk is primarily going to be